Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends to the course on maritime structures under fire, blast and explosion, which is hosted by IIT Gandhinagar Department of Maritime Engineering and under Swayam Prabha. Welcome to the third lecture where we will discuss briefly about various types and applications and functions of coastal structures and the material of construction, the type of construction, the geometric forms, and then slowly we will touch upon in the design aspect when explosion, blast and fire happens in coastal structures, how they can be protected, how they can be repaired, or what are the consequences occurring because of these unnatural events and how they can be mitigated if at all they occur in terms of estimating the risk and reliability of these kind of structures as a part of this course content. So, to know more about the design, we first talk about the classification, geometric forms, etc. of coastal structures. However, friends, many lectures under NPTEL, Swayam as well as SwayamPrabha as exposure to coastal structures, but as a part of completing the content of this course, we are also including this particular lecture in the course content of this specific lecture on maritime structures under fire, explosion and blast. So, the idea is to make the participants and the listeners aware about this without cross referring to any other parallel course in addition for basic information. If you want to know more detailed information, obviously you should go for listening to those kind of courses which are specialized in coastal structures. So, in this lecture we will touch upon the basic details of structural configuration, geometry, material, type of construction, applications and the functional aspects of various type of coastal structures, because coastal structures are major subset of maritime structures. Welcome to the lecture 3, coastal structures. Now, the question comes, why one should study about coastal structures? Coastal structures are subset of maritime structures. The primary role of coastal structures is shore protection. Unlike offshore structures where we use them for resource extraction, coastal structures have a primary role to protect the shoreline. Okay. Their design is generally governed by wave action, erosion and sediment transport, whereas in the previous case their design is governed by the material strength, the geometric form, the water depth of construction or installation, and then the commissioning, laying, fabricating, decommissioning, many aspects were involved in their design. Whereas in coastal structures design, essentially they are governed by the wave and current action, erosion and sediment transport. The fundamental difference between the coastal structure and an offshore structure in structural design is that the structural response of coastal structures is mass dominant. Essentially they are gravity based systems. So, there is no floating coastal structure. Oh, there are floating harbors, there are floating dockyards which are very rare in ideas, whereas in general coastal structures are founded to ground, they are firmly fixed on ground using piles. So, essentially they are mass dominated systems and the structural response essentially comes by inertial forces invoking these responses. Okay. There is a very interesting statement which we must remember: all coastal structures are defensive structures, because coastline protection is a very important strategic requirement of any country. Unlike offshore platforms, they do not produce energy or resources, but they manage wave energy, sediment transport and flooding. So, coastal protection is an important focus on coastal structural design, whereas the other way it was resource generation. Okay. They are essentially defensive structures. Therefore, we can say coastal structures are strategic structures of any country. Okay. They are very important. They should be designed with utmost care, even in unforeseen events such as fire, explosion and blast accidentally happening because of malfunctioning of equipments, electric short circuit, mechanical failure, impact loads caused by drop objects of cranes, etc. How you can protect them, how you can mitigate them and how you can control the consequences and the losses caused by this. That is the primary focus of introducing you to coastal structures. Okay. What are the functions of coastal structures? Protect shoreline from wave attack, prevent coastal erosion, reduce inlet filling and dredging, protect the moved vessels on the coastline, and of course, very importantly, stabilize the navigation channels. We are talking about blue corridor, effective maritime transport facilities in the peninsular region of the country. Okay. So, we have to stabilize the navigation channels, and then of course, as I said, coastal defense and flood protection becomes important. So, in fact, including tsunami warning systems, okay, then prediction of cyclones and other natural disasters are all part of coastal protection. Okay, because the most vulnerable area under these kind of natural disasters is the coastline and people living along the coastal sector, the fishermen community, etc. So, it becomes very important for a country to protect their citizens who are living along the coastline under this, against these natural disasters. So, coastal defense and flood protection becomes a very important and vital requirement of any coastal structure, which is of course controlled and governed and constituted by the Indian Coast Guards. Let us now look at what are the classifications of coastal structures. Okay. Sea dikes, sea walls, revetments, bulkheads, groins, breakwaters, jetties. These are major classifications of coastal structures. Okay. There are sub classifications within them, we will see them as we go forward, but the major classifications are these 7 of them. Okay. Let us see one by one in detail to understand the structural geometry, material used for construction, the shape and size and the cross section of the members, the structural configuration, and then about the ins and outs or important merits and demerits of these, and then we learn about them first before we start designing them under fire, explosion and blast loads. Okay. Let us talk about sea dikes. The photograph what you see on the screen now is a typical photo shoot happened on a sea dike. Sea dikes essentially are constructed to protect the low lying hinterland from flooding. So, they are essentially protective structures which are constructed to protect the low lying land on the coast side from flooding. They also help in preventing the shoreline erosion. So, these sea dikes are very long, continuous coastal defense structures, very long, continuous coastal defense structures. A sea dike does not fight waves aggressively, it survives them passively. Okay. So, they do not protect the coast by fighting against the waves, it acts as a passive protection system. The typical geometry of a sea dike is a trapezoidal cross section. Sometimes vertical front, sometimes tapered front, but the slope of this and these are different. Okay. So, usually this is the sea front. Okay, we can say the harbor front, we will remove this part. We will say this is the land and of course, this is the sea front. So, I can say this is my water level and so on. There are minor details of the weeping holes, the toe and foot reinforcement to make this kind of structural system more stable against the lateral loads. Okay. We are talking, this is a conceptual figure, do not take it granted, it is a structural drawing, it is a conceptual figure. We call this as a long continuous structure which is used for coastal protection against high waves. Okay. So, trapezoidal cross section, it is a massive gravity structure, it rests on the seabed by its weight. You can say the seaward slope is about 1 in 10 and landward slope is 1 in 3. Okay. Seaward slope is more gentle, landward slope is more steep. I think I have drawn correctly. So, this is more gentle, more steep. Okay. So, landward slope may be vertical or maybe a steep slope, but this is a gentle slope. Okay. So, trapezoidal cross section, different slopes on either sides, massive gravity structure. So, the moment I say gravity structure, you will believe that the material for construction of these usually is rubble masonry. Sometimes they also have concrete armor lining. Okay. So, usually it is rubble masonry, stone masonry, but sometimes you also have the concrete lining on the armor. The most advanced systems have geosynthetic liners to reduce the erosion content of the dikes. Okay? And of course, on the top, on this sector, they make lot of vegetation. They make lot of vegetation. Okay, to make it attractive, as well as it helps us to reduce the erosion on the top of these dikes. So, a trapezoidal cross section, different slopes on seaward and landward, massive gravity system. Sea dike is actually a coastal protection system for defense purposes. It is not built to control the waves aggressively, but it acts as a passive protection system. A typical sea dike looks like this. Okay. The material being used, as I said, is sand, silt, clay and sand. It has protected layer as rubble masonry and boulders, asphalt and concrete slabs, and of course, you have vegetation cover on the top to reduce the erosion of soil. Okay. It also has filter layers to control the seepage. Sea dikes are geotechnical structures, not pure structural systems. Okay. Let us look at the structural action of a sea dike. It has very low permeability and water tightness. Wave energy acting or counteracting on the sea dike is reduced by its gentle slope. It has got a very huge mass. It fails on different modes. One is slope erosion, other is piping, crest overtopping. That is, for example, if the sea waves get increased, okay, can even overtopple, and that can cause a failure to the dike. This is a dike. Okay. That is one way of failure. Second can be there is a failure at due to erosion happening at the seabed. They are installed or commissioned at shallow waters. The depth of this could be very less, about let us say 15-20 meters, okay, 15-20 meters. So, there can be a soil erosion happening here, which need to be protected by providing seepage holes and weep holes, so that the water drains off and the erosion does not take place. If the erosion takes place, it can also fail by differential settlement. It can also fail by differential settlement, which then induces cracks on the sea dikes. Okay? That can be another mode of failure. So, the modes of failure could be slope erosion and crest overtopping. Let us ask a question: when a sea dike is not to be constructed? Because as maritime engineers, tomorrow you will be advising the coastal protection systems for the government and so on. Therefore, one should have an idea about where they are suitable, or a counter question, where they are not ideal. Whenever you got very high initial cost involved, sea dikes are not ideal because they have very high initial cost. They have visual impact and severe environmental impacts caused on the coast side, because they create a very rigid system on the coast side, which can affect the visual impact of the coastline, because coastlines are also becoming important sector for tourism attraction. So, if you have a sea dike, people have a feeling that this is the place where there can be lot of overtopping of flooding happens, therefore, it will not attract tourism there, right. So, tourism wants a very gentle land based beach side surfaces, which is very smooth mixed with water or ocean. So, the natural beaches in Hawaii, even in Thailand, etc., looks like the beach is mixed with the water body very fluently. Capri Island in Italy, they all have a very natural beauty, scenic beauty, they attract lot of foreigners and tourist centers. When you have a sea dike, a rigid mass system constructed for a longer length along the coastline, this has a very great serious visual impact. Okay. Most importantly friends, if you construct a sea dike, it requires a continuous maintenance, because sea dikes will invoke lot of sand and sediment drifting happens between the sector where it is constructed and the length where it is not constructed. Let us say we have a coastline and you construct sea dikes here. Okay, founded for length, only this length, only this much, okay, only this much, because it is very expensive system, maybe about 1.5 kilometers, only this much. Coastline is very long, continuous, right. So, now what happens is the erosion at this part and this part are now different. There will be a sediment transport happening between these two sectors. So, if you construct a sea dike at this region, the rest of the coastline will be seriously affected, that is the trouble. So, effectively you must construct sea dike for the entire length of the coast, which is highly uneconomical. So, we say that they involve lot of initial cost, they create very severe visual impact, it requires continuous maintenance, and most importantly friends, it cuts off the access to the coast, because it is a rigid system, okay, obstructs the land or the beach and the sea, right. So, it cuts off the access. Sea dikes protects land, but at the cost of losing the coast. You lose the coastal scenic beauty when you construct a sea dike, okay. Of course, it protects the land, no doubt about it. So, they are constructed judicially when they are really required, okay. They are not casual systems to be constructed wherever and whenever you want, just because you want to invest on the coastal protection. No, you have a nuclear reactor on the coastal side, you have some important laboratory for research center on the coastal side, you need to protect them. For that sector, you construct a sea dike. For example, in Japan, the nuclear reactor located along the coast side has a sea dike as a protection structure. In Kodangulam, in Tamil Nadu also a proposal is coming up to construct a sea dike to protect these structural systems. So, sea dikes are very strong, massive, rigid construction protection systems which are constructed on the coastline for a specific purpose, okay, because it has got lot of visual impacts and other issues related to the scenic beauty of the coast. So, it is not a very common system to be constructed. The next one is the sea wall. It is more or less similar to sea dikes. You can see a sea wall. The rigid wall with tapered cross section, okay, and it protects of course the coastline from even very high tides, and partly for tsunami protection people also propose to construct sea walls, okay. Sea walls are massive structures. So, we can now look at the structural system. So, again a trapezoidal cross section you can see, and mostly they are of concrete, okay, because rubble masonry cannot have an integrated structural system like this. So, they are mostly of concrete or prefabricated interlocking blocks, essentially concrete blocks, interlocking blocks, okay. They are otherwise called as armored blocks. So, sea walls are generally constructed to prevent flooding due to storm surge and waves. There are sectors on the coastline where very often flooding takes place and coastal erosion is happening. For example, in Odisha coast, we have this trouble, right. So, we have a lot of coastal erosion happening. Similarly, in Kerala coast, we have this trouble of coastal erosion happening. So, these places of severe coastal erosion are identified using coastal vulnerability mapping, and this length of the coast are chosen where no other alternative can happen. Sea walls are recommended to be constructed. They are very expensive systems friends, they are very expensive, okay. If you look at the Thailand coast, okay, Thailand coastline, near the scenic beauty of Sriracha campus or Sriracha land and so on. You have got white sand beach in Thailand, where some of the sectors of this coastal line are protected by sea walls, because you have Thai oil company whose plant is located on the coastline. So, to protect the refinery unit of Thai oil, people have constructed sea walls for not a longer length, for a small length. So, they are essentially constructed to prevent flooding. So, it is a coastal protection system. It protects the roads, promenades and buildings built along the coastline for certain length, while they also preserve the natural beach profile. They do not affect, they do not cause extensive soil erosion like sea dikes. Sea walls also help us to protect, preserve natural beach profile. They are generally constructed parallel to the shoreline. There are different types of sea walls you can construct. A vertical face, which is called reflection based sea wall, a sloping face, stepped profile and a curved profile, depending upon the architectural aesthetics required along the coastline. Sea walls protect specific stretches, not the entire coastline. Okay, they are constructed only for a short stretch, because they are very expensive system. Rubble masonry is used, whereas the outer line is again constructed with concrete. You can also have mass concrete vertical walls or asphalt concrete surfacing walls for improved visibility. The one which you see here is an asphalt concrete surfacing wall, which has got lot of weep holes. You can see weep holes. Water is allowed to pass through them and drain off the other side. Okay. So, you can have a vertical surface, tapered and tapered cross section. You can have a section like this. So, it is the land side and this is the sea wall. Okay. So, you can have a vertical surface, it is for a shorter length, and this is a cross section. Okay. Can be masonry, armored concrete or armored blocks or concrete solid walls. So, this is a stiff system. Okay, resists lateral loads by its weight and stiffness. So, it is a rigid system. Okay. They are very expensive. So, they are only constructed at places or at sections parallel to the coastline where no other coastal structure can offer protection. For example, if you find a coastal line which has got severe erosion problem, then one can go for the sea wall type construction. Okay. The structural action sea wall, as you see here, they have low permeability, water tightness. They have wave energy reduction taking place because of the gentle slope and high mass, parallel to what you saw in sea dikes as well. The failure modes are same as that of the sea dikes. Sea walls often protect one place by damaging the rest. Okay. They protect one shot where they are constructed, but the rest of them are severely damaged. The construction type can be sloping front, vertical front, and stability of this wall depends on the toe protection. There are many examples where sea walls have failed. One classical example, failure of Kamaishi sea wall in 2011 tsunami in Japan. Sea walls also have a very typical hydrological problems. It increases the mean water level at that sector. It also increases wave heights as per the report provided by IPCC 1987. So, a stronger wall constructed along the coastline does not always mean a safer coast. A stronger wall for that segment will protect the coastline, the rest of the coastline may get affected very severely. Okay? That is a very important point which as a maritime engineer we must register in our mind. Okay? Let us see what are the different failure mechanisms by which sea walls and sea dikes which are rigid structures can fail. One is an overtopping and scouring mechanism, which is one of the most common cause of failure. When water waves higher than the wall flow over them, they create high speed water jet on the landward side. This current scours, erodes the soil at the base, causing wall to destabilize, and wall will overtop or collapse. Okay? It can also fail by hydrostatic pressure. When the water level rises gradually, it causes flooding by building high hydrostatic pressure at the heel. When this exceeds the structural limits of the design, it fails. The third one can be settlement. As I said, the erosion will cause settlement of structures, so subsidence or settlement can also be a problem where sea walls can fail. Under massive earthquakes of 9.0 magnitude and above, which occurred in Japan 2011 during tsunami, ground level subsides by about 1 meter. This lowers the protective height of the wall, causing functional failure. Okay? When the wall gets lower, then the wave overtops the wall and the wall itself is completely washed away by the sea waves. That happened actually in tsunami 2011 in Japan. The third type of construction is similar to what we saw earlier, but both of them had similar solid construction, whereas remitments are actually pitching. You actually create a gradual slope. I will put a cross section here. I draw a cross section. So, what you do, you put a pitching on the surface. A lining, stone lining. You must have seen this in most of the hill roads where people used to protect the ghat roads using pitching. So, this is actually rubble stone pitching. The very purpose of this pitching is to prevent or at least reduce soil erosion. Okay. Alternate could be people have started using geosynthetic fibers. Or reinforce them. Okay. They got geosynthetic fibers as well as reinforcing them, so that the slope stability is achieved. Okay. The purpose of a revetment is again a shoreline protection from soil erosion. It maintains the natural beach slope. Okay, helps us to maintain the natural beach slope. You will see mostly in all beautiful scenic beauties along the coastline of Italy, like for example Naples, okay, Capri, you will find lot of revetments constructed for an entire length of the beach side to maintain the natural scenic beauty of the beach. They are flexible alternative to sea walls. They are more flexible, where sea walls are more rigid, whereas they are very flexible. They have a sloping profile. They have a layered system, armor layer, filter layer and core soil. Revetments are actually energy absorbers, not reflectors. They do not reflect energy, they absorb them. Okay? If sea wall fight waves, revetments hug the waves. Okay? This way you can easily understand the keyword, the important functional difference between a revetment and a sea wall or a sea dike. They reflect waves, they fight waves, whereas revetments hug the waves, they absorb the waves. Okay? They absorb the waves. The common materials used for revetments are armored stones, concrete blocks, geotextiles or geosynthetics, And of course, you put vegetation in the top layer to prevent soil erosion. You must have seen this a common practice in most of the ghat roads along the hill stations. People use this even in case where they built houses at higher terrains on sloping grounds, people use construct revetments to do this. So, revetment is not actually only a important system for coastal protection. Actually, the system of a revetment is to stop or to control the landslide, okay, to improve ground slope stability. So, these are structures used to maintain the slope or strengthen or stabilize the slope of the natural ground. So, they are constructed to protect them. Of course, they are protected on the coastline to reduce the erosion of the coastal lines. The structural action of revetments are very simple. They dissipate wave energy through porosity. They allow water to go through, they absorb waters. Okay? Through porosity, they dissipate high end waves. It controls the surface runoff. It reduces reflection compared to sea walls. Revetments have a very short service life, it is about 20-25 years. After that, they get disintegrated and broken into pieces. Okay? When revetments are preferred, interestingly friends, if there is a low cost investment and you want to do it on a semi-urban or rural coast where you can do or think of temporary solutions, okay, one can go for revetments. Sea wall is rigid and reflective, revetments are flexible and absorptive. Okay, they absorb waves, sea walls reflect waves. Sea walls are rigid systems, revetments are flexible systems. Sea walls are constructed with concrete or armored stone blocks, revetments are rubble masonry lines with geosynthetic fibers or layers. Okay, the service life of this system revetments are about 25 years, whereas sea walls can sustain about to 75 to 80 years, long term investment. Okay. So, friends, in this lecture, let us look at the summary. We talked about different types of coastal structures, why are they constructed, what is a typical geometric shape of them, and what materials are used to construct them, and where are they constructed. We also saw classifications of coastal structures. There were 7 of them. We discussed in detail about the sea dikes, sea walls and revetments. We understood that sea dikes and sea walls are rigid systems. They are designed to remain stiff. Okay? Therefore, they resist wave loads or lateral loads by their strength. They are constructed for shorter length because they are expensive. Okay? They protect the coast, but they also damage the coast, the rest of the part. Of the coast. Whereas revetments are flexible systems. They are also constructed to protect the shoreline. They absorb waves, whereas these people reflect waves. Okay? The lifespan of these structures is approximately 25 years. The material used for construction is essentially coarse double masonry. One can also have armor block lining and geosynthetic reinforcements. So friends, in this lecture, we started learning about the coastal structures, their geometric shape and size, their structural action, the modes of failure, methods of construction, do's and don'ts of at least 3 types of structures: sea walls, sea dikes and revetments. You will follow the next sequel of the lecture to know more about the remaining types and the classifications. Thank you very much. Namaste.